Hiya, welcome back. I'm sorry for the absence. Work commitments, coming home and having to do things every weekend round here. But anyway, you can hear a ticking noise in the background. It's my garage heater because the temperature at the moment is 5.5 degrees apparently. Right, now to get on with this, I'm kind of going back because I started doing these cotter pins, but I haven't done all these little ancillary bits that fasten onto here. So that's what I'm going to do and make this micrometer screw plus attachments. We have a dust seal there and an end plate at the end there, which is also shown here. That holds the tension spring in. And we have a micrometer screw, which is this bit with a threaded piece there. We then have a cap that fastens to this body here that protrudes, and this sleeve, which has the divisions on it, is attached and held onto this screw with two ball bearings and a spring, so you can reset the divisions that are on it. It's, as they say, it's not a true micrometer screw, it's this piece here. What it's basically for, I think, is when you set your tool up against the wheel, you can then zero it, and if you're doing multi-facet end mills or wherever it is, you can come back to a zero. You can reset that round to a zero, so then you can wind it off or wind it on. I think it's wind it off. Well, it's wind it that way, so that will go away from the wheel. And then obviously you can move the cutter around, bring it back to zero. So obviously this needs to adjust, but it's more important just kind of keeping it to a zero, I'm assuming. So we've got some bits to make. So first thing, I am going to turn this body 107. It's a body made out of cast iron I'm going to go for a fine M10 thread because I have a fine M10 thread set, tap set, and that's what I'm going to use because I haven't got any 3/8 BSFs. I've been having a look and I'm a bit short on the ground for English stuff. So this bit first, and then I'm going to make this end cap, which is a basic end cap. I'm not going to do any of the holes as yet. I'm going to do all the turning work. That end cap there, and then I'm going to do these aluminium ones, and then I'm going to come back. So see you in a bit. Right, I'm over here at the lathe. I've got a new bracket on this camera holding it up. Hopefully I'm a little bit nearer. Now there's not much in the way of telling you which way around you want to do it, and whether this cast iron is for anything else without digging through the instructions, but I've got it held in my hard jaws. Got enough room here. I'm going to flick the face up first and drill it and tap it for the thread. I want to do the face. I'll take a light skim on the OD first off, and then I know once I've drilled it I will check the OD to see whether the drill's knocked it out at all, which I hope it doesn't. It made the nut alright that I did. I am going to go most of the way through here. I'm not going to drill it fully in case this cast iron is used for something else, because at the moment it seems quite a bit long. But I'm going to turn the OD, just a rough OD. I'm not going to finish it off, and I'm going to turn this diameter here and not finish that off either. I'm going to wait. My garage at the moment is about 8 degrees, and you might have heard a bit of a ticking before, and that's a heater trying to warm it up. I would like to make everything at least 10 degrees upwards, so I'm around a mean temperature for when I do other pieces. Obviously in the summer it gets warmer. I mean, you live in a different part of the world that's warmer you may not recognise a little bit of expansion and contraction as much as what we might do here. But fingers crossed. We're up to 9 degrees anyway, so things are working. I fast forwarded on this section because all I'm doing is skimming the face, slight skim on the OD, centre drill, and then putting the drill down ready for tapping. I just mentioned here I'm drilling 1 1/8 inch, which is just over the full length of the job, so I can part it off into clear space. Now this is cast iron, and obviously it's a very fine thread, so this is going in quite easy by hand. Oops, knocked my camera stand. And obviously, because it's a blind hole, I'm just doing this by hand. Try and stop it in that. There, that's just bottomed out now. I've finished off now with a plug tap. I might have to run it through obviously once again, but I've left it in there and put a clock and an indicator on just to see what this is running out. And I have 1, 2.5 thou. That's the tap running out now. I think 2.5 thou is good enough really for a tapped hole. But at least it's not mad running out all over the place, so I'm quite happy with that. And we'll see what we like when we do the other thread. Now I'm going to finish this off. Now I'm up to a nice balmy 12 degrees, which is, to me, it's a nice, it's not room temperature, but it's nice enough. Everything feels slightly warmed up in here now. I'll finish the OD off, the length and the OD, and then this is going to be parted off, and there is a little flange on the other side to finish off. Just another fast forward section where I turn down to the diameters, leaving about 20 thou or so, I can't remember, left on for finishing. And then I'm taking, because I left the OD 20 thou up, I'll finish that off now. Quick check with the ruler. Unfortunately, this is a metric ruler. We're on 28mm, and it's approximately 27 if we convert back, so I'm a milli over length, which is what I want to do. So I'll part this off now. I have taken out my drive for the feed. There's no point in accidentally leaning against one of your levers, which can happen, and all of a sudden your drive goes that way or that way and disaster occurs. Go. Right. Now I've swapped my hard jars out for these soft jars. I am a believer in soft jars. I've worked in a jobbing shop a while ago, well, a long time ago, and we use 3 jars. I believe if you've got a decent 3 jar and you're lucky enough to be able to get hold of some soft jars, you can use them quite good. A lot of people do, or the ones that fit on, that bolt on. Kitagawa make them, and other people. So I put this in. Yes, I have revolved it round a couple of times, and I don't know if you see the clock, but we are getting half a thou. So as far as I'm concerned, that's good enough. I'm going to measure across this flange to get a thickness, then I'm going to take it down for the boss. Right, people want to know if I dropped any bollocks. Yeah. Eagle-eyed among you, if you saw anything, if I was close enough with the mic, I misread my mic. What a prat. Luckily, I've misread it, as you do sometimes, up, not down. So, yeah, there's me going back to Imperial and saying, yeah, I'll keep up to speed with this. I'm 25 thou up. It's not good, is it? Obviously this is where I fast forward, because I've got to try and catch up by my mistakes. Taking 25 thou off the front side and then turning it round, clocking it all back up and doing the back. Now, I'm not saying for anyone to polish how like I polish, because obviously you don't want to get your hands inside here, but well, we all know what we do that we're not supposed to do on machines. Anyway, that's finished. Now you'll notice I will have to machine a little bit. Ooh, I thought I did, but no, it fits in. There we go. That's nice. Yes, it sticks out a bit. It's the casting. So like I say, the radius on my casting is a little bit short. Don't know why, it's just the way it is. But anyway, I think we'll blend that at a later date so it all looks nice and neat. But anyway, that's the turning work on that done. I shall rerun the tap down there to make sure that's clear, and that's one bit at least finished.